question number 45. It says choose the end behavior of the graph for each polynomial function. We have A, B, and C. So I want to give you guys a little chart that I gave to my students. I know it's kind of small, so I'm going to zoom in so you guys can kind of take a picture. And this is for end behavior, and I apologize in advance for my awful handwriting, but I try my best. So, when you want to determine the end behavior of a polynomial function, you must examine the leading term. The leading term is the term with the highest degree of the polynomial. And when you find the highest degree of the polynomial, you want to examine the degree, which is the exponent, and you want to examine the leading coefficient, whether if it's positive or negative. So, if you have a positive leading coefficient with an even degree, the end behavior will rise up on the left and rise on the right. If you have an even degree but a negative leading coefficient, it will fall on the left and it'll fall on the right. So on and so forth. Odd degree, positive leading coefficient, falls on left, rise on right. Odd degree, negative leading coefficient, rise on left, falls on right. So we're going to answer A, B, and C based on this. So for A, right, the leading term is going to be negative 3x to the fourth. So that means we have a negative leading coefficient because the coefficient is negative 3. The degree is going to be even. Because my degree is even and I have a negative leading coefficient, the function end behavior will fall to the left, so I'm choosing B, and it will fall on the right, so I'm selecting option B for both. Falls to the left and falls to the right. Alright, let's reset, and let's change our color up, by the way. Let's use blue. Now we're going to do the next one, which is going to be B. My leading coefficient is going to be, my leading term is going to be 5x to the fifth, because that has the degree of my polynomial, which is the highest exponent. The degree is 5. 5 is an odd number. The leading coefficient is a positive number. The leading coefficient is 5, positive 5. So that means my end behavior is going to fall on the left and rises on the right. Please don't confuse the two. The degree is the exponent. The coefficient is the number that's being multiplied in front of the variable. Alright. Now let's answer C. But C is in a different format. C is actually factored. That polynomial is factored. But I can still find the end behavior on based what I have. So to find my leading term, you're going to multiply the leading term of each value that is being multiplied, the leading term of each factor, of each multiple. We have a negative 2 on the outside, so my leading term. The negative 2 on the outside. Now here we have an x, but this x, that quantity is being raised to the second power. So the leading term here is going to be x squared. Because when I distribute that out, x minus 2 times x minus 2, I'm going to have x squared minus 4x plus 4. X squared is going to be the leading term of that part at least. And here I have x to the power of 1, which is x to the first. So I'm just going to put an x to the first here. Now remember, when you're multiplying terms with the same base, you can add the exponents. So x squared times x to the first, 2 plus 1 is 3. My leading term is going to be negative 2x to the third power. Once again, my degree is going to be odd, but this time I have a negative leading coefficient because 2 is negative, which means my end behavior is going to rise to the left, or rise on the left, rises to the left, and it's going to fall to the right. So whenever it's factored out like this, perform the same operations as I've done here. Before I end this video, right, sometimes you may have a polynomial in the form of, let's go back to black. And I'm going to, I'm going to write it on top. Actually, let's zoom out a little bit. Okay. Let's say you had a polynomial, f of x equals to 3x squared, x plus 4 to the third, x minus 1, right? Now to find the leading term of that, you're going to do the same thing. But in this case, you're going to multiply the 3x squared to find the leading term with here the x to the third with the x to the first, because there's an invisible one here, the x to the first. And those are known as multiplicities when you see the exponents like that. Once again, multiply the same base, add the exponents. So that's going to be 2 plus 3 is 5, 5 plus 1 is 6. My leading term will be 3x to the 6th power. And then from there, you can determine your end behavior by the chart that I've given you. So that's another example that you may encounter on your exam. That's more like a supplemental problem, if you would say. Okay, guys, that's it for number 45. I'll see you soon.